Right, week 10, video 8, inheritance. So, as the name says, this introduces a new idea in object-oriented programming called inheritance, which is closely related to, indeed more or less the same as, the use of subclasses. So I fudged over something in the previous video. I talked about how there were two players, player 1 and player 2, and there were subclasses of a class, they were instances of a class player. That's a little bit of a cheat because we were originally going to have two different types of players, human players and computer players. And that suggests that there are two different classes, and this starts to raise a little bit of a worry. Is there common code in those that should be shared, and if so, how do we share it? And the mechanism for sharing is now what we're introducing, the idea of inheritance. First of all, to give you a little bit of a real-world analogy, when we classify the animal kingdom, we break it down into invertebrates and vertebrates. These don't have a backbone, these do, and then the vertebrates are classified into fish, amphibia, reptiles, birds and mammals, well, we're a subclass of mammals. So we can say that humans are a subclass of mammals, are a subclass of vertebrates, are a subclass of animals. So how do we do this sort of idea or capture this idea in programming? We use inheritance. This is very useful. It is used more in what we call statically typed languages like Java and C# rather than in dynamically typed languages like Python and PHP, Ruby, whatever. If you want to know what I mean by dynamically typed and statically typed, type it into Google. You could do that now if you like. I'm going to move on. I now want to draw your attention to a little bit of a fudge. When I wrote class color, I skipped out a little piece of syntax. And the syntax I skipped out, which was a default behavior, was that actually I want this to be a subclass of class object. That is, its parent class is the class of objects, which is everything. All Python objects are in some sense subclassed from object, but maybe not directly, maybe indirectly. I'll explain that in a few seconds. So there is a class object already there. I can go O as an object, and I can do its dir, and what you get may look a bit familiar, all of those things, which were the methods that we got before with our color. And the reason we got them before with our color was because we inherited them from the superclass, which was object. So that's what that bit says. Having got one of those, I can actually have a class color. I can have a class transparent color, which is a subclass of color, which is a subclass of object, and so on. And so this might have an additional attribute, which is transparency, and so on. So another analogy with real-world stuff, let's look at people in a university. So all students have a name, an address, an age and an ID, and they have an academic record, what they're currently enrolled in, things like that. Academics have a name, address, an age and ID, but they have a tax code and a salary. General staff they're paid on a slightly different basis. They have a tax code, but they have a pay rate. And if you were writing a simulation of a university with classes for students, academics and general staff, if you weren't careful, you would find yourself replicating a whole heap of code relating to names, ages, addresses, etc. And there's a motto in programming, DRY, don't repeat yourself. I hope it's obvious why, because it makes maintenance a pain. You change one of them, you've got to go and change all the others because you made a mistake. It's much harder. So what we're going to do instead is use this idea of inheritance to capture the commonality. So here is that information written in a diagrammatic form. So a person has a name, an address and an age. A student, that arrow means, is a subclass of, or as we say, inherits from, a person. A student also has student ID and list of courses. I don't say they have a name and an address and an age. That is implied by that arrow. Necessarily they have them because they're a subclass. Staff, general rate, academic. You can look through that, make sure you understand it. I'm going to move on. Just a little bit more terminology. The term subclass, I've used it already, means that it's a child class that it inherits from its parents, grandparents, etc. Superclass is the opposite thing. So if A is a subclass of B, then B is the superclass of A. and inheritance means that all of the parents' variables and methods can be directly used in the subclass. So I should have said really that all of the parent objects, variables and methods can be directly used in the subclass objects, variables, and in the subclass object. Sorry. So I'm going to illustrate that with a piece of code, and here we have a piece of code that represents a person. It's in the class person.py. Please go through, try to understand that. If I were to run that, I can create a bod who's a person, capital P, who's a person, and they have a name and an address, so I'm going to put them there, and they have an age, 23, and I can now print the bod. I can just type bod in like that. I can greet the bod, so I can go bod.greet, and it says, hello, my name is Fred. So make sure you understand that before we move on. Pause the video if necessary. So now I want to move on to the subclass example. So the subclass of a person, here was a student, has a student ID and a list of courses. So here they are. So they have a name and an address and an age, and they have a student ID. And, oops, I forgot to assign that in this version, student ID. And a list of courses that we initially put in as empty. I could have passed it in as a parameter. I chose not to, arbitrary decisions. You'll notice there's some repeated code here. This code there is exactly the same as in person, which should sound alarm bells, and indeed it's bad. We'll fix that in the next video. And the student has a new method to enroll in a course. So I can say, after I've run this, I can say, stud is the student, our friend Angus, who lives somewhere and is of age 19 and has a student ID 1, 2, 3, 4, 5, 6, 7, 8. If I print the stud, now this gets a little bit interesting, what's going to happen when I print them? We haven't defined an explicit str method or repr method, so surprise, surprise, we get the one from the parent, which doesn't include the student ID number or the list of courses. We'll address that in the next video too. I can, however, enroll a student in a course, stud.enroll in course, cosc121. And so now if I ask for the stud's courses, I discover they're enrolled in cosc121. I can enroll them in another course, 122. What a good idea. Everybody should do that. Stud.courses, and I get both of them. So I've just done my first example of subclassing. It's a little defective. As you can see, when we print the student, we don't get their ID number, so it's not a true representation that's reversible. I can't get the student back because I don't have enough information. And it says they're a person, which is true, but actually they're a student. So I'm going to look at fixing those in the next video. Bye for now.